Well, I was hoping to be presenting on the theme of nature-based solutions to climate change at a meeting in Venice, but unfortunately I find myself, like so many of us, at the bottom of the garden, doing our best to remain in contact with one another during this difficult time, but on issues that could not be more important still, namely the matter of how we're going to be dealing with the longer term issues presented by climate change and wider environmental degradation. And my presentation in Venice was going to be around the theme of nature-based solutions and how we can look at the opportunities for tackling climate change through looking at the natural world and not only emissions coming from transport and industry based upon fossil fuels, obviously hugely important questions, but by no means the only ones. I've spent the last 35 years working on different elements of conservation and climate change, and over that period have developed some views around the extent to which these two sets of issues map over each other. And today I just thought I'd share a few thoughts around the headings that seem most relevant to me. So the first one is the extent to which nature is a sink and a way of catching carbon from the atmosphere. So it's about mitigation. Nature and healthy natural systems are also very important for how we adapt to the impacts of climate change. And then thirdly, there are a set of issues linked to the conservation of the natural environment and how we can align that with climate change in order to avoid ecosystem degradation and species loss. And then there is a fourth set of issues linked with wider ecosystem services, including fresh water security, which of course in turn is linked to food security. And so for me, all four of these headings, they are very important to consider in the context of how we tackle global warming going forward. So on the first one, maybe just a few thoughts around the extent to which natural systems are very important in catching and holding carbon that would otherwise be in the atmosphere. First thing to say is that compared with fossil fuels, this set of questions is quite hard to measure. When you mine a ton of coal from a coal mine or take a ton of oil from an oil well, turn it into fuel and burn it, we got a pretty good idea of how much carbon dioxide is being released. More difficult with, for example, deforestation, and even more difficult still with forest degradation, when indeed the system is still there in some form, but has been damaged and carbon has been lost, but we don't really know how much. So this is a difficult set of data points that we grapple with. But having said that, we do know that this is a pretty huge component of the challenge. And indeed, over many years and looking back at different reports, you can see a figure of around 1/5 of carbon dioxide emissions coming from deforestation. That's a figure that's widely cited by different studies and seems to be a more or less consensual figure. Having said that, if you look at forests and the extent to which they remove carbon and hold it from the atmosphere, then some people would argue that a modest program of reforestation, protecting existing forests and preventing their degradation is more like 1/3 of the solution to the climate change mitigation challenge we face. And the reason for that is because when you remove a forest, not only are you releasing the carbon, you're also halting its ability to catch more carbon in the future. So it's a kind of a double whammy. On the one hand, we're releasing carbon, and on the other, we're removing a very powerful carbon pump. So forest degradation and deforestation are a very significant portion of the overall climate change mitigation equation, and various measures have been talked through at the international level, reducing emissions from forest degradation and deforestation was the so-called REDD agenda, R-E-D-D, which put in place some level of consensus at the time of the Paris Accord for countries to cooperate in working to reduce deforestation, and indeed with other global accords, notably the Bonn Challenge Accord, setting out some targets for the world to reforest, and of course both of these having very significant carbon upsides. But it's not only forests that are important for the climate change mitigation side of the conversation. Soils are also hugely important. Now, soils hold carbon in the form of organic matter. So if you can imagine photosynthesis, creating biomass, taking carbon from the atmosphere, turning it into plant materials. Those plant materials sooner or later die, and as they die, they go into a period of degradation and the decomposition phase. And during the course of that decomposition, there is a level of organic matter, that decomposing plant material that's captured in soils. Now, the higher that level of decomposing material, then the more carbon is out of the atmosphere again. Now, one of the problems that we've had over many, many years is how modern industrial farming has tended to deplete organic matter. What we've done is we've treated soils in rather abusive ways through industrial farming, and the organic component of soils is reduced, and we've been able to carry on producing food by using vast amounts of industrial fertilizers, which of course also come with a large carbon footprint of their own. So there's another double whammy here in terms of being able to reduce our reliance on artificial fertilizers with a big carbon footprint, if only we can restore soil fertility, which is not only good for carbon, but also good for food production by lifting up that organic matter in the soils. And there was an initiative that was put forward by the French government at the time of the Paris meeting, the so-called 4 in 1,000 initiative. And that was the idea of increasing soil organic matter by 4 parts per thousand per year as one major, very important strategy to remove carbon dioxide from the atmosphere. And there's a great deal to be said about the ways of doing this, more sustainable agriculture, agroecology methods that rebuild soil health, not only as a strategy for sustaining food production, but also as a carbon reduction and carbon storage strategy. So agricultural soils globally could be hugely important. Well, they are hugely important, but could be hugely important as part of our mitigation program going forward. But there are a subset of soils globally which are purely made of organic matter, the so-called peat. Now, peat is accumulating layers of vegetation that's rotting either very slowly or not at all over literally thousands of years, making a semi-permanent store in the ground. And even though peat soils cover only about 3% of the land globally, they hold about a quarter of the carbon that's in the ground. So these are very significant systems. And of course, not only are they massive carbon stores, when they're degraded, and sometimes degraded in quite spectacular ways, they become a massive emissions source. I was in Indonesia in 2015 and watched the effect of massive peat fires sweeping across the landscape. And those peat fires were burning on the ground where there was once tropical rainforest, and the rainforest had already been cleared, but people were burning the land in order to clear it for agriculture. And as they did that, fires got out of control. And peat, being made of pure organic matter, meant that in places the land actually caught fire. And those fires were burning on an epic scale across Sumatra and across Borneo, leading to daily emissions that were estimated to be bigger than the entire United States economy, with all of its aircraft, trucks, houses, factories, and all the rest. So this is a huge opportunity to be able to do something major for mitigation of climate change through the protection and restoration of peatland ecosystems. Alongside forests and peatlands, in terms of how we can mitigate climate change, are also a series of coastal ecosystems. I just named 3 very briefly. One is mangrove forests, another is salt marshes, and another is seagrass beds. And all of these ecosystems in different ways hold lots of carbon, and not only in vegetation, but like soils, also in the sediments in the ground. And some salt marsh ecosystems, for example, can hold as much carbon, and indeed considerably more carbon per hectare than a tropical rainforest. So these systems are very significant carbon stores. They tend to be occurring on quite small land area comparative to tropical rainforests or to Arctic peatlands, for instance, but nonetheless very significant. And the more that we can protect those systems, the more we can do to mitigate the climate change challenge that we very often look at through the lens with more emphasis on transport and industry. So this is very significant from the point of view of mitigation. is the conservation, restoration, and enhancement of forests, of soils, especially peatlands, and different kinds of coastal habitats. So having registered that very big opportunity for climate change action through the recovery of nature, let's also just think briefly about the question of adaptation. So we already have more than 1 degree of global warming. That's already causing impacts globally, witnessed in the form of different kinds of extreme conditions, whether they be storms, heat waves, flooding events, droughts, and all of these are causing economic and social harm. But it is the case that we can reduce the impact and create more resilient systems for humans if we recover the natural world in ways that not only catch carbon, but also anticipate these extreme events. So, for example, forests help us to cope better with the effects of flooding in this part of the world, and indeed many countries. You can see how where deforestation is very high, flood risk goes up. And conversely, where forests are still intact or have been replanted, flood risk can go down. The same thing could be said about healthy soils. When healthy soils have a high level of organic matter, they can hold about 20 to 30 times more water than soils where the organic matter has been depleted. And so by creating healthier soils, we can reduce runoff and interrupt the flow of water across the landscape so that it doesn't fill up rivers or drainage ditches so quickly, thereby reducing the size of flood peaks. Instead of going like that, they can go more like this. And that helps us to avoid some of the risks that come with those extreme rainfall events. And similarly with peat soils, across much of the British Isles where I live, the uplands are covered with layers of peat. Some of those layers of peat are very thick. And those layers of peat, they act like enormous sponges. As the rain falls on the hills, they slow down the flow of water. And not only do they slow down the flow of water, they also make the rivers much cleaner, bringing benefits for fishing and indeed for public water supply at the same time. And of course, those systems, as well as being very important for reducing flood risk and cleaning the water, they're also holding vast amounts of carbon in the landscape. So real priorities to be protecting those kinds of systems. And as we look at the effects of drought going forward, systems that hold lots of water, whether that be an upland forest, a peatland, or healthy organic soils, which are able to contain so much more moisture, this is going to help us to adapt to the effects of drought, especially in relation to agriculture going forward. So those systems that can store and hold moisture, both ends of the spectrum, they're helping us avoid flooding, and they're also helping us to avoid severe drought impacts. Coastal systems too, of the kind that I mentioned a moment ago in terms of the importance that they have for mitigation, those systems also very important for adaptation. So healthy salt marshes, some people regard them as being like horizontal levees. If you're trying to protect a low-lying coastal area, you can build a sea defense that's kind of that shape, or you can have a sea defense which is much wider, which is that shape. And this flat coastal system we know is much cheaper to maintain. Of course, it requires no engineering, no concrete, and in the end is much more effective because a salt marsh, as it traps sediments from the sea, it actually rises with sea level. So we've got inbuilt adjustment from natural systems that can help us adapt to climate change in terms of the effects of both sea level rise and extreme coastal storms, just through making sure they're in good natural health. And the same thing goes for mangroves as well. Self-adjusting sea defenses that otherwise would cost us many billions of dollars to construct, our cheapest and most effective option in being able to adapt to some of those coastal changes that we know are coming and which we can already see in different parts of the world. So once you start looking at it like this, you can see that actually the things that we need to do for mitigation and the things that we need to do for adaptation, actually, they're the same thing. Conserve and restore forests, restore agricultural soils so that we can have not only sustainable agriculture, but also those mitigation and adaptation benefits. And then, of course, looking at those coastal systems that are so important for nature, but also help us to adapt and to catch carbon. The third part of this, which I'll emphasize now, links to that importance to nature and the extent to which these very same systems that catch and hold carbon and increase resilience, they are also vitally important in addressing the parallel global environmental emergency that sits alongside climate change. Obviously, climate change quite rightly gets an enormous amount of attention in environmental discussions, but it's one of two major issues, the other one being the degradation and decline of ecosystems and the loss of species that's occurring with that. And that decline of the quality of nature is going hand in hand with the carbon problem. And the more that we can do to make our response to the carbon issue the same as what we need to do to conserve species, the better. And looking across the world today, there is a mass extinction of animals and plants taking place, and we know very well what we need to do to halt and reverse that. It's the same thing we need to do in order to be able to adapt and mitigate the CO2 issue through the natural environment, conserve habitats, create larger landscapes, larger landscape areas of natural systems that are connected with one another, and build mosaics of landscapes whereby agriculture and the needs of humans are much more embedded into the land rather than replacing the entire natural system with human demanded goods and services, whether that be plantation timber, industrial agriculture, or livestock farming. We can do that, and there are examples in different parts of the world where these things do go together. And also, we should recognize, as we think about that landscape level conservation of the natural environment, that it's not only the carbon benefits and the adaptation benefits that we get from conserving natural systems, and it's not only the wildlife benefits that come with that either. There are also other ecosystem services that are vital for human well-being that also rely on those very same systems. And one that I'll mention briefly is the question of water security. So I'm sometimes struck by how it is not often appreciated that when you talk about tropical rainforests, there is a clue in the name. They produce rain. It's not only rain that falls upon them, but those systems, through a process of massive scale transpiration, are driving entire weather systems at the level of literally thousands of miles. So water falling onto the Great Plains of North America, one of the world's most important breadbaskets, and in the La Plata Basin in South America, in the region of Sao Paulo, down into Paraguay and northern Argentina, where vast amounts of food are being grown. Those food systems are dependent in some part on water being pumped into the atmosphere by the Amazon rainforest. So as we cut down the Amazon rainforest, it's not only carbon that we're also losing some level of water security, which in turn will impact in the long term on food security. So there are many, many reasons why we need a joined up response. And having spent many years looking at these questions, it strikes me that the key to success in how we meet the twin challenges of climate change and the degradation of nature is to take an integrated approach. I just share with people one or two things I've written. This book is called What Has Nature Ever Done for Us? And in it, I chart many of the points I've just made in some detail, and with a technical reference list, which you can find at my website, www.tonyjuniper.com. You can find that there. Similarly, with this book, What Nature Does for Britain, there's a great deal in here about the importance of peatlands and soils, amongst other things. And this more recent volume, which was published just a little while ago, called Rainforest, Dispatches from Earth's Most Vital Front Lines. In this book, I talk about the importance of those systems, both from the point of view of trees and peat, but also crucially from the point of view of water security. And as I say, there are all the sources, the technical sources that you might like to look at. You can find at my website to give you some sense of the literature on all of this, but it's all readily available these days. And the thing that comes through, however, on all of that technicality and all of that information that we now have, as I say, is this need for an integrated approach. Is it possible for us to conceive strategies whereby we cut carbon in the atmosphere, we adapt at the same time, we save the natural environment, and we promote food security and livelihoods? Can we do that? Well, yes, we can. And that is the job at hand. It's not only about transportation and energy. These things are critical, but we need to take that wider view. And this year, as we're all sitting at home, we were expecting 2020 to be a breakthrough year for the natural environment on the global stage, and for there to be big opportunities, both with the COP26 that was going to be hosted by the UK, and also COP15 of the Convention on Biological Diversity, which China was going to host later this year, a major COP for that process too, whereby there was going to be an attempt to put together a plan for the next 10 years. And both of those things, they will happen probably now in 2021. And as we come to our advocacy and our recommendations to governments and private sector and subnational governments, and we think about the future of these subjects, it seems to me absolutely critical that what we have to do is not only negotiate a strong outcome at COP26 on climate change and a strong outcome on biodiversity at COP15 of that process, but to also negotiate a joint outcome whereby the synergies and the connections between those two important political processes are reflected in what they both say at the end of the day. And that's a huge opportunity. And if there's any good thing to be said about us all having to sit at home right now, the good thing is that we've got a little bit more time to make that work. And hopefully on the far side of this COVID crisis, the world will at least have a little bit more appreciation of what risk can mean. Because we've been warned about global pandemics for years, the risk wasn't taken seriously, but we've been warned about climate change and ecosystem degradation too. Those risks have also not been taken seriously. Perhaps in the aftermath of this, we'll have a different common collective view at the global level about what risk means, and we'll take an integrated and joined up approach to meeting that risk into the future. It's been a great pleasure to share a few ideas. I'm very happy to engage in Q&A through a separate link at some point soon.